Okay, we're looking at the projectiles mini test. So this is the solution to question 1. So we've got a projectile. So we're told the angle of elevation is 50 degrees and the initial speed at that angle is 45 meters per second. It doesn't hit anything on its path, so it's going to go up and then come back down and hit the ground there. And we are asked for the time it takes to reach its maximum height. So its maximum height is going to be there. And what is special about that point is that is where the vertical velocity is 0. So the first half of its journey, it's got a positive vertical velocity. Gravity is slowing it down. At that point, its vertical velocity is 0, and then it's got a negative vertical velocity. Okay, so I need to think about the vertical motion. So I'm going to take up as positive. So the initial velocity vertically, so basically I've got a right angle triangle. So I want the I want to split that 45 meters per second up into its well, I just need its vertical component. So that's opposite the 50-degree angle. So the vertical velocity is going to be 45, and I'm just using SOHCAHTOA. So if it's opposite, it's going to be 45 sine 50. Acceleration is going to be due to gravity, and I'm taking up as positive, so that's going to be minus 9.8. I want to find the point where the vertical velocity is 0. I'm after the time, so I'm trying to find t. So I'm going to use v equals u plus at. So v is 0, u is 45 sine 50, a is minus 9.8, and t is what I'm trying to find. So 9.8t, if I add that over, is 45 sine 50. If you just leave it as 45 sine 50, it just means you don't have to bother picking your calculator up until you need to do just this final calculation. So I'm going to divide that by 9.8, and I'll just stick that whole thing into my calculator. So 45 sine 50 all divided by 9.8, oh, give me a syntax error, is 3.51755, but because I've used G to two significant figures, it only really makes sense to give my answer to two significant figures, so that's going to be 3.5 seconds.